Okay, for those of you who are interested, we are going to look back to our population data modeling. And here we are going to see that you can also develop algebraically the exponential formula without using the first data. So without using the point 0,472 here. So let's just have a look. Maybe for some reason you think you would like to use point C and let's say point F for algebraically trying to find exponential formula that fits this data in your graph here. So point C, so that would be this point here, 20,420.84. And point F will be 50,825.81. So if we are going to do so, then using the basic form of our exponential function, we could substitute the x and y value that we have chosen. So in this case, let's say it's going to be 520.84. And then the x value later on will be 20. Then I'm going to just fill in the rest. So that will be equal to a times p power 20. And then by using the next point, we are going to get another equation. And this time, then we will substitute 825.81 and x is 50. So what do we do now? We have actually two equations with two variables a and b, with two unknowns a and b in this case. So we can solve it simultaneously. So in this case, I am going to try and divide the second equation by the first equation. So if we do so both sides, we are going to divide the second one by the first equation. This is what I'm going to have. On the left hand side, I will have 825.81 and divided by 520.84. And on the right hand side, I will have a times p power 50. Remember the second equation divided by the first equation. And on the denominator, I will have a times p power 20. And then from here, I could see that couple of things, a and a. I could actually cancel this out. And then I will have p power 50 divided by p power 20. And what do we know when we have an exponent with the same base and we divide these two expressions? We are going to subtract the exponent. So what do I have? I'm going to have p to the power of 50 minus 20, so which means p power 30. And on this side, I will have this number here. So what happened is, in the end, what I need is only p. And therefore, what I have to do, basically, is to actually take the 30th root of both sides. So if I do so, I'm going to use a different color here. So basically, both sides, I'm going to take the 30th root. So if I then do so, on the right hand side we will have just b, and on the left hand side we will have to calculate using our calculator. So let's try and do that in our calculator, 30th root. So how do we do that? We can take, we will use the math help here, and this is the one that we need. So x root of something, number 5, but the thing is we cannot just choose that at the moment. We will have to type first 30 because we are looking for 30th root, and then afterwards we press math and choose number 5. So in this case we are going to take 30th root of 825.81 divided by 520.84. And what do we get? In this case we have p is equal to 1.015 to 3 significant figure. 1.015 to 3, to 3 decimal places. So once we have the value of p, then of course we can substitute that back to either one of these equations and find the value of a. So for instance, if I take the first one, I will have 520.84 equals a, and then if you still have it in your calculator, you could probably just fill in here later on your answer, still in the long decimal places. But here at the moment, I will just put what we have just gotten before. So in this case, power 20. So knowing that, then your a value will be actually 520.84 divided by 1.015 power 20. So if I again use my calculator to do it, now you see here, I still have my long p value over there. So what I'm going to do is I'm going to type 520.84 divided by, here I'm just going to say second answer, so which means we are going to take the one that we have just had before, the answer previously, and then that to the power of 20. So what do we have here? So we will have 383.0485 and so on and so on. So I'm just going to take to 3 significant figures, 383. So then here in this case, the value of a is 383. So this is an alternative way algebraically to find your model, exponential model. So in this case, then you will have a formula that says 383 times 1.015 power x. So maybe you would like to try that and have a look, and good luck.